Applying congruent triangles. By definition, congruent triangles have congruent corresponding parts. So if you can prove that two triangles are congruent using a shortcut, then the remaining corresponding parts are congruent as well. What that means is that if we can prove that two triangles are congruent with a shortcut, maybe like side, 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 which didn't require us to know anything about the angles, we can actually conclude that the corresponding angles would be congruent. This property is referred to as Cpctc, which stands for corresponding parts of congruent triangles are congruent. For example 1, we're going to prove that angle 1 is congruent to angle C. Okay, we're going to prove that this angle is congruent to this angle. And to do that, we're going to prove that two larger things are congruent first, which is prove that these two triangles are congruent to each other. And if we do that, then we can say the corresponding parts that we didn't initially know to be congruent must be congruent. All right, first let's take a look at the picture and see what information has been given to us. Okay, we've got double markings on AB and BC. All right, so we can make that our first step. We can say that line segment AB is congruent to line segment in corresponding order, that would be CB, okay? All right, so line segment AB is congruent to line segment CB. That would be given. All right, also AD, all right, line segment AD is congruent to CD. That is also given by the single mark. In addition to that, what would we need to know to prove that the triangles are congruent? Well, if we think about our shortcuts, we've already got two sides here. So if we can prove that the third side is congruent, we could use side, side, side. Or if we can prove a certain angle is congruent, we could use that. The easier route here is going to be doing the side, side, side shortcut because these two triangles actually share BD. They share that side. So step 3, BD, now I'm referring to BD as part of the left triangle that I have here. That would be congruent to the right triangle side, would also be called BD. All right, those are congruent by the reflexive property. And with that, we have proven that the two triangles are congruent using side, side, side. But we have to state that. So step 4, for step 4, we can write triangle ABD would be congruent to triangle CBD. Reason is side, side, side. And last, we can actually state what we needed, which is that A is congruent to C. And the reason for that is Cpctc, which stands for corresponding parts of congruent triangles are congruent. What we do is we prove that the triangles are congruent using the information that we have in a shortcut, and then we can state any of the remaining pieces, which could be angles A and C, or maybe the angles up top here or at the bottom. We can then state that those are congruent because they would be corresponding parts of congruent triangles. All right, for example 2, we're going to be asked to prove that AB is congruent to DE. In the picture, this is AB, and this is DE. All right, a little bit about what's happening in the picture here. This is a surveyor. And what the person is trying to do is figure out the distance out to B. He's trying to figure out where B is. Okay, but B is actually located in water. So he's over here on the ground, B is out in the water, and he can't actually get out to that spot. However, if he's really clever about things, he can figure out the information that he needs on land and just transfer that information over to the water. All right, so what he starts with are 3 points, A, C, and D. Point A is going to be a really special point. That one is going to make a perpendicular with the edge of the water and B, so he's got a right angle there. All right, then D is going to be any random point that's just off to the side. Point C is going to be the midpoint of A and D. It's going to split that up. All right, and then E is going to be the most interesting of those. It has to be perpendicular from D, but when he figures out where E is at, he's going to make sure that it is lined up with C and that point that he's interested in figuring out over there. Okay, so there's a lot that goes into the construction to get this set up. But ultimately what he has done is he's created a right triangle over here that's actually congruent to the one that we have over there. And if he can figure out what the length of DE is, that would be the same thing as AB because those would be corresponding parts. All right, our job is to prove that the two triangles are congruent, which would then allow us to say that DE is congruent to BA. That's what we're trying to get at here. All right, step 1, information that we do have. Point A was decided to be a perpendicular at the beginning, and so is D. Okay, so angle A is going to be congruent to angle D. Okay, in a way that was given, you could write down that it was given. We could do that because we set that problem up to be that way. You could also just state that they're both perpendiculars, but I'll go with given. Step 2, AC is going to be congruent to DC. All right, that is going to be congruent because C was chosen to be a midpoint from A to D. Okay, so that would also be given. We can state it that way. All right, so we have those pieces, and no matter what shortcut that we use, okay, no matter what shortcut that we use, we have to have at least 3 things here. So we've got an angle, we got the perpendicular angles, we've also got a side length, we have that, we have to figure out one more thing that would be congruent between the triangles. Okay, so what would that be? All right, so the third piece that we have is actually going to be these two angles right here. We've got some vertical angles. Let's go ahead and just call them angle 1 and 2. That way we don't have to mention as many letters here. Angle 1 is going to be congruent to angle 2 because we have vertical angles. So that's not given. We have to identify that one. The given is all the stuff that the surveyor had set up. Okay, the vertical angles is something that we identify. All right, so those are congruent, which will be another pair of angles. All right, so what I have over here to the side makes it look like it would be angle, side, angle. But I do need to look at the picture to make sure that it wouldn't actually be maybe angle, angle, side. All right, so if I look at this triangle, the two angles that are being used here do have that side as an included side, which means that this does work out. It is going to be angle, side, angle. And of course, the same thing that we have over here. We've got an angle, then we've got the side, and then the angle. All right, so step 4, we can make the statement that triangle BAC, we'll go in that order, can't see it, BAC, that triangle is congruent to EDC. All right, reason is going to be angle, side, angle. Again, be very careful that the way that we wrote the previous steps, that it does actually match up to the shortcut that we're going to use. If it doesn't, just make sure you state the correct shortcut. All right, so if the two triangles are congruent, that would mean that all the corresponding parts would be, which includes BA and DE. All right, so line segment AB is going to be congruent to line segment DE. Reason, Cpctc. Corresponding parts of congruent triangles are congruent.
Wait, what?